Hey everyone, welcome back to Space Bat, where we explore the wonders of the cosmos, one star at a time. Today we're talking about red dwarfs, the rebellious little stars that are everywhere in our galaxy, yet full of surprises. Let's dive into what makes these stars so unique and why they don't play by the same rules as the rest. First things first. What exactly is a red dwarf? Well, they're stars, but not like our sun. Red dwarfs are much smaller, cooler, and dimmer. So much so that if you were looking up at the sky, you wouldn't even be able to see most of them without a telescope. But here's the wild part. They make up 75% of the stars in the Milky Way galaxy. While they're everywhere, they like to keep a low profile. Our understanding of red dwarfs started in the 1860s with Italian astronomer Angelo Secchi, who was one of the first to classify stars based on their spectra, or the light they emit. He didn't know it at the time, but his work paved the way for the discovery of red dwarfs. In the early 1900s, Annie Jump Cannon, working at the Harvard College Observatory, took star classification to the next level. She organized stars by temperature and brightness, identifying M-type stars, the coolest and smallest stars, which we now know as red dwarfs. Then, in 1915, Scottish astronomer Robert Innes discovered Proxima Centauri, the closest star to our solar system. And guess what? It's a red dwarf. This showed us that red dwarfs aren't just common. They could be right next door in our galaxy. Now let's talk about why I call them rebellious. Unlike our sun, which shines steadily and calmly, red dwarfs are known for their wild, unpredictable flare activity. These stars frequently release enormous bursts of energy, called stellar flares, that are much more intense than what we see from our sun. Some of these flares are thousands of times stronger, making red dwarfs seem like they're having mood swings or throwing tantrums, like some 2-year-olds. These flares happen because red dwarfs have extremely strong magnetic fields. The star's entire structure is constantly churning, which twists and tangles their magnetic fields, causing them to snap and release those powerful flares. This unpredictability makes red dwarfs dangerous for any planets orbiting nearby, especially those in the habitable zone. Imagine living on a planet that gets hit by massive radiation bursts every few days. And while most stars burn out after a few billion years, red dwarfs are ultra efficient. They burn their hydrogen so slowly that they can live for trillions of years. Compared to stars like our sun, which will last about 10 billion years, red dwarfs are like the immortals of the star world. They live way beyond what we usually expect from a star. Totally rebellious, right? Now let's talk about one of the most exciting aspects of red dwarfs' eyeball planets. Because red dwarfs are so dim, planets need to orbit very close to their star to stay warm enough for liquid water. Many of these planets are tidally locked, meaning one side of the planet always faces the star, while the other side is in constant darkness. This arrangement creates what's known as an eyeball planet. The side facing the star could have a warm, defrosted zone where liquid water exists, while the rest of the planet remains frozen. These planets might look like an eye from space, with a central liquid region surrounded by ice. Here are a few examples. TRAPPIST-1d, one of the 7 planets in the TRAPPIST-1 system, about 40 light-years away. TRAPPIST-1d is in the habitable zone of its red dwarf star and is likely tidally locked. Scientists think that the side facing the star could be warm enough to support liquid water, making it a prime target in the search for life. LHS 1140b, located 40 light-years away in the constellation Cetus, this super-Earth is larger than Earth and might also be tidally locked. Currently, it is thought it is a frozen planet, except the one part that faces the star that could have life under the water, safe from the radiation from its star. I wonder, if that is how flat earthers see Earth. Proxima Centauri BR, orbiting the red dwarf. Proxima Centauri, just 4.24 light-years away, Proxima b is in the habitable zone and could also be an eyeball planet. Since Proxima Centauri is known for its flare activity, any potential life on this planet would have to contend with bursts of radiation, making it a challenging but fascinating world to study. Now, these planets are not known to have a thick atmosphere, which is needed for anything on the surface to survive. If they did indeed have a thick atmosphere, the planet could maintain that near the red dwarf, it could be instead a Hycean world, meaning it could have liquid oceans all around the planet, but its atmosphere would have to be very dense for distributing heat around the planet. Eyeball planets challenge our traditional ideas about where life can exist. Even though they orbit small, faint stars, they might still offer the right conditions for life in those defrosted regions. Here's another twist. Red dwarfs don't go out in a blaze of glory like massive stars. They just slowly fade away over trillions of years, eventually cooling into dark, cold objects called white dwarfs. Because red dwarfs burn so slowly, none have yet reached the end of their life cycle. They're truly the quiet immortals of the star world, staying around long after other stars have burned out. Thanks for joining me on this journey through the world of red dwarfs, their rebellious nature, and the unique planets that orbit them. Until next time, keep looking up.